Alexander Friedmann, 1922. First to derive solutions to Einstein's equations that predict an expanding universe.
Georges Lemaitre, 1927-1931, proposed the universe began from a primeval atom-connected expansion theory with observed redshift.
Edwin Hubble, 1929. Observationally confirmed expansion via galactic redshift established Hubble's law, provided the empirical proof that space is expanding. Alan Guth, 1980, introduced cosmic inflation, explained early rapid expansion and large-scale uniformity. Saul Perlmutter, Brian Schmidt, Adam Rees, 1998, discovered accelerating expansion. The quantum physics interpretation of cosmic evolution as a dynamic expanse field geometry rather than a purely relativistic metric expansion. The diagram depicts the origin of the universe from an exponential inception event, left, followed by an early superluminal expanse epoch in which spacefield expansion exceeds relativistic light speed constraints without violating local Lorentz invariance. The quantum physics interpretation of cosmic evolution as a dynamic expanse field geometry rather than a purely relativistic metric expansion. The diagram depicts the origin of the universe from an exponential inception event, left, followed by an early superluminal expanse epoch in which spacefield expansion exceeds relativistic light speed constraints without violating local Lorentz invariance. As the expanse field dilutes, structured matter emerges within stabilized density layers leading to the galaxation epoch and the present expanse regime. The funnel geometry represents decreasing spacefield density and increasing expanse velocity over cosmological time. The far right region denotes future expanse domains potentially entering superspeed expanse regimes governed by dark zero-point energy and vacuum field dominance with speculative branching into multiversal expanse structures. Time progresses longitudinally while radial widening represents the magnitude of the spacefield expanse rather than energy-driven. The current epoch reveals a universe where space expands at an unprecedented rate marked by low-density conditions that challenge our understanding of matter. In this extraordinary expanse, the influence of vacuum and zero-point fields eclipses traditional matter density, setting the stage for future exploration. As we gaze into the far future domain, the cosmos may transform dramatically, entering a realm where expanse velocities dwarf the limits of relativity. In this scenario, matter-bound regions become increasingly isolated, while the overwhelming influence of the expanse field heralds a new era driven by vacuum dynamics. In this new reality, the very fabric of space is transformed, creating a stunning visual of universes racing into the unknown, while isolated matter struggles against the expansive vacuum that reshapes its destiny. As humanity reaches for the stars, exploring the new frontiers of superspeed expanse, the mysteries of vacuum dynamics unfold, revealing profound questions about our place in an ever-expanding universe. The cosmological space field is properly treated within a framework distinct from relativistic kinematics. While special and general relativity govern local inertial motion and space-time curvature produced by mass energy, they do not fully characterize the global dynamics of space-time expansion. Cosmological expansion describes the evolution of the space field itself rather than the motion of matter through space-time, and therefore operates under different constraints than relativistic velocity limits. As a result, the cosmological space field constitutes a separate physical regime, one in which superluminal recession, non-inertial expansion, and large-scale gravitational behavior emerge without invoking infinite energy, infinite mass, or violations of local causality. Relativity remains valid locally, but it is not exhaustive when applied to the global structure and dynamics of the expanding universe. Within this interpretation, the space field is not merely a solution embedded within relativity, but a foundational medium whose expansion. Relativity constrains motion within spacetime, whereas the cosmological space field governs the evolution of spacetime itself. The two are not dynamically equivalent. As massive objects warp the fabric of spacetime, they dictate how smaller bodies travel through this intricate framework, shaping their movements and trajectories. This interaction reveals the delicate balance between the force of gravity and the velocity of objects, creating a perpetual cycle of motion that defines our universe. Such stellar events not only alter their immediate surroundings, but also contribute to the ongoing evolution of spacetime, connecting past, present, and future in an intricate cosmic narrative. These colossal interactions illustrate how the cosmos is in a constant state of flux, evolving through forces that are both powerful and awe-inspiring, shaping the very essence of reality. Every observation reveals more layers of complexity, urging humankind to explore deeper into the fabric of existence, striving to understand the fundamental forces that govern the cosmos. As we gaze into the depths of space, we are reminded of our quest for knowledge, seeking to decode the laws that dictate both the minutiae of particles and the grand design of the universe. The installer space field exists separately from the celestial planetary gravities, untouched by the physical intermingling that governs the movements of celestial bodies. In this extraordinary realm, the dynamics of the installer space field allow for an existence devoid of the time constraints that affect celestial bodies. Scientists are beginning to understand how this separation opens possibilities for new forms of exploration untethered by the physical laws that bind planets. This innovative spacecraft is set to embark on a journey where the rules of time and gravity no longer apply, paving the way for unprecedented discoveries. As they lift off into the unknown, the crew feels a mix of exhilaration and trepidation, ready to explore realms that challenge their understanding of existence. Inside the spacecraft, the crew monitors their progress, witnessing the astonishing phenomena of the installer space field as they traverse this extraordinary dimension. Drawn closer to the swirling vortex, the crew is filled with wonder, contemplating the mysteries that lie within this captivating phenomenon. As the spacecraft stabilizes within the vortex, the crew steels themselves for a transformative experience that could redefine their understanding of space and time.
Relativity that mass and energy are but different manifestations of the same thing, a somewhat unfamiliar conception for the average mind. Furthermore, the equation E is equal mc squared, in which energy is put equal to mass multiplied with the square of the velocity of light, showed that very small amount of mass may be converted into a very large amount of energy, and vice versa. The mass and energy were in fact equivalent, according to the formula mentioned above. This was demonstrated by Cochran and Walton in 1932 experimentally.